This is linear algebra. We're going to study properties of determinant. We define how to calculate determinant of each metric. So here is a question you're going to have this section. How row operation impact calculation of determinant? What is the best way you're going to calculate determinant? We're going to use property of determinant to find or calculate determinant matrix, guys. So here is a property. I'm going to put the three things, guys. Clearly understand that we're going to do the very simple example. I'm not going to go prove of each property or theorem, just with the example. I'm going to explain to you. Let's just start with, guys, right here. Interchange of two law. A metric going to be 2 by 2. So we're going to find determinant of A, which meaning is 1 times 2 minus 2 times 1, right? So this one gonna be 2 plus 2, that is 4. So we're gonna do row operation. How gonna change determinant after row operation? So let's gonna be, this one is metric A. We're gonna after interchange to row, so you're gonna have new metric. So row 1, row 2 interchange. So meaning is 1, 2, 1, negative 2. I'm gonna put this one is B, guys, okay? After row operation, so we're gonna find determinant B gonna be 1 times negative 2 minus 1 times 2. That's negative 2, negative 2, negative 4. So find the relation between the two determinant. Determinant A is a 4 right here, guys. Determinant B gonna be negative 4. So you're gonna say determinant B gonna be negative determinant A. So when you do the interchange of two law, determinant sign gonna be changed. That's the first property, guys. Second part is here, we're gonna do replacement. So I'm gonna do negative 1 first row plus second row and gonna be second row. So you're gonna be negative 1, positive 2. Let's say this is metric A. So new metric, you have B metric gonna be right here. B metric gonna be after this replacement. 1, negative 2, 0, and 4. So what happened, guys? Let's calculate this determinant of B after replacement. So determinant B gonna be 1 times 4, 1 times 4 minus negative times 0, that's the 0, that's the 4. What do you notice? Determinant A gonna be 4, determinant B gonna be 4. Here is a really important property of determinant. Determinant A, determinant should be same. So replacement, it doesn't change determinant, okay? Next one is the scaling. Scaling is like you're gonna times number or divide by number. We're gonna times one fraction, that's division, right? After this one, let's say this one is A metric, we give it. You're gonna times the first row 3. So you're gonna have this B metric gonna be 3, negative 6, 1, and 2. So like gonna be this one B metric. Let's calculate the determinant B. That's gonna be 6 minus 6. That's the 12. What happened, guys? What happened here? Look at this one. Determinant A gonna be 4. So 4 times 1 make 12. So determinant B gonna be 3 times determinant A, right? This is 4. Where did you get the 3? 3 is coming for this scale. Okay? Another way you write this one, guys, this one is determinant A. So let's write down the metric form. So this one, B metric, determinant B gonna be 3, negative 6, 1, and 2. So this one is here, first row. What is common factor? You take it out, common factor 3 right there. Then you're gonna see 1, negative 2, 1, 2. Exactly same as determinant A, right? This is 3 determinant A. That's a scaling property, guys. So remember the 3 property when you calculate the determinant. Interchange, change the sign. Replacement doesn't change any determinant. Scaling number is take it out. Common factor, take it out. Then you're going to calculate this one, okay? Why this is so important? Why this property is so important? Because matrix size is bigger, like a 3 by 3, 4 by 4, it's very hard to calculate determinant matrix A. So we're gonna using this property after operation. Change the matrix to the Angela form. Looks like much simpler than original one. We calculate the determinant. Previous section we talk about diagonal, right? So we're gonna make this one is diagonal triangular matrix, guys. So triangular matrix is here is a number right there, guys, and everything is zero. It doesn't matter what you hear. So when you do triangular matrix, then determinant of this matrix, guys, determinant of this matrix gonna be determinant B gonna be times each entries. That's this property is very useful, guys. That's we're gonna do it by using the raw operation, guys. Let's do this one, guys. Okay, we wanna calculate determinant A, guys. So what do you wanna do, guys? Okay, what do you wanna do? Let's do raw operation to reduce to the Angela form. So this form, guys. Okay, let's do this one. So what are you gonna do first? Let's just start this one, guys. Determinant A meaning is, let's just start this one is, that's making sure that's the line. It's bracket. That's different notation. 1, -4, 2, -2, 8, -9, -1, 7, 0. So what is our goal? Here is the, let's make a triangular matrix. So below here is make 0, guys. Look at this one. This make 0, this make 0, this make 0. That's how we're gonna do it, guys. Okay. How gonna be determinant change that you have? Make sure you understand that, guys. Look at this one. So what kind of operation you need? This -2 is 0. So you're gonna write down here 2 times R1 plus R2 going to R2. Replacement doesn't change right here, guys. Replace determinant doesn't change, okay? So that's why I put equal. Another one here, bottom. R1 plus R3 go to R3. Still, this is replacement. Determinant doesn't change. So this one gonna be, guys, after this operation, you have 1, -4 and 2, 0, 0, -5, here 0, 3, 2, here. Guys, make sense? Replacement doesn't change. Now, look at this one. We want to make a triangular matrix. So here, bottom should be 0. Look at very carefully. Here is a 3, here is a 0. So I'm going to interchange low here, guys. Interchange low is what happened here. When you interchange low, sign going to be changed. So you're going to see interchange here. R2 going to be R3. When you interchange raw operation, make sign going to be changed, okay? Okay, so here is a negative 1, 4 and 2, 0, 3, 2, 0, 0, -5. Oh, you have the triangle matrix. Guys, look at this. You did a great job. Here is here and diagonal entry. Below here, all 0. So this determinant is very simple. Negative 1 times 3 times -5. That's it. So this one is a 15. So that's the purpose of using this property of determinants. So make A matrix is Angela form, especially this triangle matrix, and find the determinant. Okay. So let's have another example, guys. So you can practice it, and then you can check later. Just pause the video. You're gonna do by yourself. Okay. All right, let's do the determinant A. Keep in mind these 3 properties right there. I'm gonna write down the top, guys. Interchange, sign gonna be changed. Replacement, determinant, same. Scaling gonna be take out common factor. So let's go this one, guys. Here, -1, 3, 2, 5, 2, 7, 3, 2, 1. So I'm gonna do replacement. You guys have this should be 0, this should be 0. So what kind of operation do you need? Okay, what do you want to do here, guys? Right here, 5R1 plus R2 gonna be R2. Another one, 3R1 plus R3 go to R3. Determinant doesn't change. Guys, make sense? Determinant doesn't change. So you have negative 1, 3, and 2. 0, 17, 17. Here is 0, 11, 7. So determinant doesn't change at all. Now, what do you see? Second law. Look at the second law. Here is a second law. There's a common factor in 17 and 17. You take it out. So this one is just 17. Negative 1, 3, and 2. 0, 1, 1, 0, 11, 7. See? So we're going to make triangular matrix. So what do you have to do? This should be 0, right? So what kind of operation you need? So negative 11 R2 plus R3 go to R3. That case, determinant doesn't change, guys. So you're going to have 17. Matrix going to be negative 1, 3, and 2, 0, 1, 1, 0, 0, negative 4. Right? So you have diagonal, triangular matrix. So how can find the matrix, determinant of matrix? So here's 17 times, first one is negative 1 diagonal. Entries, 1, second, third one, negative 4. That's going to be 68. Okay, so you already know how to do the row operation to reduce the rows. That's why we're going to using this property to calculate determinant of any metric, guys. This one is a 4 by 4 metric, guys, much bigger, guys. This is a 4 by 4, guys. Look at this one. This is a 4 by 4. This bar meaning is determinant, guys. See the determinant, not the metric. So we want to calculate this 4 by 4 metric, right? So how can calculate determinant? So you're going to thinking about a couple of things. Here is, I'm going to write here. This one is diagonal entry. So below this diagonal, you have make 0. But already here is a 0. Here is a 0. So you're going to make this 4 entry, make 0. That's going to be, we're going to do it right here, guys. Okay. Let's do this one. So we're going to say metric 2, negative 8, 6, 8, 3, negative 9, 5, 10, negative 3, 0, 1, 2, 1, negative 4, 0, 6. Okay, let's do it, guys. So I'm going to do replacement. We talk about replacement. Replacement doesn't change anything. You're going to do how many? So you do this one going to be 0, this one going to be 0, this one going to be 0, guys, okay? So before that, so here is your 2, but first row, look at the first row. What is common factor? Can you see that? You can take out 2, right? So I'm going to do 2, 1, negative 4, 3, 4, 3, negative 9, 5, 10, negative 3, 0, 1, 2, 1, negative 4, 0, and 6. Any other row doesn't have any common factor, so I'm going to do first row only, okay? Now, we're going to do this should be 0, this should be 0, this should be 0. So replacement doesn't change any determinant. So you're going to change anything, just replacement. So you're going to do 3. So 3 times, negative 3 times R1 plus R2 going to R2. I'm going to do write down everything. 3 times R1 plus R3 going to R3. One more. Negative 1 R1 plus R4 gonna be R4. So you're gonna do 3 replacement, but doesn't change anything, guys. Doesn't change any determinant. So you're gonna put here, guys. You can take a pause. You're gonna do it. All right, here is a 0, 3, negative 4, negative 2. Here is a 0, negative 12. Here is a 10 and 10. Next one is a 0, 0, negative 3, and 2. That's you did. after determinant. Okay, now guys, what do you see here? You're gonna see now, we're gonna talking about diagonal, right? We're gonna have this one, this one, this should be 0, this one, right? How many 0 you're gonna make right here? This one should be 0, this one you should be 0. Does that make sense? Okay, let's do this one. Let's do one by one this time. So I'm gonna do determinant doesn't change, guys. So I'm gonna do 4 times R2 plus R3 going to R3. That's what you're gonna do it, right? So I'm gonna do 2, 1, -4, 3, 4, 0, 3, -4, and -2. Guys, what? 0, 0, -6, and 2. Okay, so you have 0, 0, -3, and 2. Okay, so you're almost there. So what do you have? This one should be 0, right? This one should be 0. How can I make this one is 0? Okay, so you have to do, what do you have to do? Here is -6, right? So 1.5 R3 plus R4 go to R4. Guys, more creative. You're gonna do make it 2 times 1, -4, 3, and 4, 0, 3, -4, and -2, 0, 0, -6, and 2. Last one gonna be 0, 0, 0, 1. Okay, you finish it, guys. Look at this one. Last one. 1, 3, -3, 6, 1. Diagonal entry only counted below diagonal order 0. This determinant is going to be 2 times, 1 time, 3 times, -6 times 1. So this one is going to be -36, guys. We using raw operation reduce to the envelope form, then you find the determinant. Okay, 2 more property I want to talk about last part. A is square metric. Determinant always square metric, guys. And then transpose. Guys, remember that's the notation of a transpose. Transpose is what? Transpose of metric meaning is A transpose meaning is what, guys? Row and column is interchange, right? So this first row go to first column, 6, 1. Second row gonna be second column, 3 and 2. What happened here? So let's find the determinant A. 2 by 2 is easy, right? 6 times 2 minus 3 times 1, 12 minus 3 is 9. How about determinant transpose? How can get? Here, 6 times 2 minus 3 times 1, that's gonna be 9. So your conclusion is determinant of transpose of metric A, exactly same determinant of metric A, guys. The row and column change doesn't change the determinant, okay? Another is property gonna be multiplication. AB metric is gonna be square metric. Then we wanna find, guys, look at this one. This multiplication of metric. And then we're gonna find the determinant. Determinant meaning is number, guys, okay? Then each determinant you have multiply, okay? So let's prove this one, guys, okay? AB metric, guys, remember multiplication of metric? So what is it? 3, 1, 4, 1. That's going to be 24 plus 1. 3, 1, 6, 1, 3, 2. That's 80, 18 plus 2. Right? Then here it is 3, 2, 4, 1. That's going to be 12 plus 2. 3, 2, 3, 2. That's going to be 9 plus 4. So you have 2 by 2 metric. 25, 20, 14, and 30. That's a metric. Let's calculate the determinant. What is determinant? AB. So we have metric of AB. You're going to find determinant. That's going to be 25 times 13 minus 20 times 14. So that's going to be 45. That's number. Determinant is number, guys, okay? So let's find determinant A. We already find determinant A gonna be 9. What is determinant B? Determinant B gonna be what? 4 times 2 minus 3, right? So A minus 3, that's gonna be 5. So this one is determinant A times determinant B. So 9 times 5 is 45. So we have conclusion is determinant AB equal determinant A times determinant B. That's useful property you're gonna use.